Michael, the floor is yours for an 8 to 10 minute kickoff, and off you go. Please, Michael, the floor is yours.
Thank you. Good morning. I've just come out of a discussion with Gilberto Camara from INPE in Brazil, and it's exactly about the paradigms. We have basically in this room two paradigms, the Malthusians and the Schumpeterians. And since he's into monitoring, his score is 2-2, and we will see what we will do out of this session. I have an Austrian bias, I have to say. So let me start with my talk, and I elaborated quite a lot on the title. It reads out from noble goals. I will go into detail on that one, to confused local strategies. And I will actually present a solution, a technical solution which we developed at IIASA for local strategies. And it will always be about the wicked problems, which is always in the room, reconciling different sectors, different goals, and so forth. Johan Rockström was voted the most influential person on the environment in Sweden, but he's probably also the most influential in this room here, because this is the most shown graphic at this conference, and it's about the planetary boundaries. And I will show you some analysis we did at IIASA, just focusing on the planetary boundaries, land use nexus, and see how policies and current technologies could do in order to bring the globe back to its boundaries. What we do here is we built for the last 10 years or even longer an integrated cluster of models culminating in the Globiome model, where we actually take up a bottom-up approach. We take production possibilities in agriculture, forestry, and ecosystem management into economic models on engineering different technologies, and then really bring the different sectors together through market clearing mechanisms. But not going too much into detail on the technical things, we are still around, and we are about 50 people from my group in this room. You can consult them and get the details of it. But what does it mean in terms of planetary boundaries? So we were running one no planetary boundary goal scenario, which is the first one there. And then we did 4 different policy scenarios. One policy scenario refers to the land use boundary, and we actually simulated it through stopping deforestation, mostly coming out of the RED discussion under the UNFCCC. And then the second policy scenario we did on climate change. We imposed a climate tax on the land use sector. And then finally we did the biodiversity scenario, taking out lands with high biodiversity value from land conversion. And then what we did later is the last one. We combined all the different policy scenarios, and in order to make them feasible, we had to introduce a diet shift. Otherwise, those other targets would not be possible anymore. What you see is here the different land cover groups: shrubland, grassland, short rotation plantations, forests, and croplands. And I will just, what you see here is you have a tendency of land sparing along this axis. Basically, the biodiversity scenario dominating actually the other ones. What you also see here is if you just do a single sector policy, so you protect the forests, what you see is a leakage into other biomes. So here I put into red, by protecting the forests, you actually move more and more into the shrublands. So those are the things you actually get from integrating the different sectors. But let's look how these policies perform with respect to the other planetary boundaries. The first one is water. What you see here on these spider graphs, you see the boundary, which is green, and if the dot is out of the boundary, you're still out of the boundary in 2050. And what you see here is, with respect to biodiversity, remember, this was the best performing scenario with respect to land use, but in terms of water, it's the worst performing. And this is because in order to do land sparing, you need to irrigate more, and therefore you abstract more fresh water from rivers and aquifers and so forth. So here you clearly see there's a trade-off between biodiversity and water. So you cannot get it all at the same time. But there are other things which are actually more synergistic. And here you actually see nitrogen and phosphorus. And what you see is that with respect to the climate scenario, you actually get a lot of nitrogen and phosphorus benefits, mostly through also land sparing, in the sense that you actually apply more per hectare on your location, but overall you use less land, and therefore you on the global scale you actually have less phosphorus and nitrogen input, which is quite interesting. And this also points to the fact that such policies actually need to be coordinated over space, even going into trade issues. Very important. And then finally what you see is with respect to greenhouse gases, of course the climate scenario and the oil and diet scenario are performing best, but what you also see is with respect to the baseline, a biodiversity scenario by itself or a land use scenario would also bring co-benefits with respect to greenhouse gases. So just to conclude on this part, what you see is co-benefits are important, and this points at policy coordination. But what we also see is, and you have seen that from the spider graphs, many dots are outside of the boundaries in 2050. So policy is not enough. And current technologies. What we need are the new transformative technologies, something like what Nina presented yesterday, but many others. And we actually know many of those, and we do impact assessment of those. But let me just show you one example of a transformative technology which we developed at IIASA, and it's actually a social technology. And this points to our frustration as analysts doing global land use assessments when you actually see how uncertain our basic input data sets are. Those are these agreement maps with respect to cropland and forests in spatially explicit. And you actually have outside you have the hyperglobe, and you can actually look at those things in more detail in the next break. So what we did is we launched a GeoWiki, and I will come back to this in more detail, where we actually look at land acquisitions, which we get from the land matrix database. And you see here the yellow boundary. And we actually are looking for evidence of settlements within these lands which were acquired. And of course, the combination of two are actually give rise to risks with respect to disputes and conflicts in those areas. In order to map out those things, we have here a GeoWiki system where it's very simple for every one of you to just map out and look at this frame and see whether there are settlements in there, high, low, or medium, and whether it's cultivated. And you can also give your evidence. And what the outcome of such a crowdsourcing platform is this is after one weekend all of Ethiopia mapped out by volunteers. And this is, after 2 weeks, we basically mapped out all of Ethiopia with respect to cultivation. And this map is actually superior to any other global land cover map showing cultivation within 2 weeks. And what we also do is then, of course, what we get the overlay with respect to the settlements, and we are currently working on a risk map with respect to land acquisitions that happened already. And what I would like to announce is we want you to actually engage in this process, and we are launching an IIASA conference competition tomorrow at IIASA. And we will give you 3 weeks to mobilize your organizations to contribute to this project. And we will give a prize for the organization that hits most And I hope IIASA will not win because we are a small organization. And I will stop here. Thank you very much. Please note down the webpage and send it to your employees.